All right, we are working on 3.1, complex numbers. This is part 3. So now we're going to talk about multiplying and dividing complex numbers. Multiplying is actually pretty easy. It's very similar to multiplying when you have any variable, with one exception. There's one step beyond that you have to deal with. So let's go ahead and get started. I'm going to just go ahead and do this multiplication. So I have a 1 times a 1 is going to give me 1, and 1 times 3i is going to give me a 3i, and then 2i is times 1 is going to give me a 2i, and then 2i times 3i is going to give me a 6i squared. So first thing I'm going to do is I'm going to collect the obvious like terms. So I've got this here. So I'm going to have 1 plus 5i plus 6i squared. Now stop and think for a moment. I squared is the square of the square root of negative 1. Okay, and I realize that's quite the mouthful, but it's what it boils down to is I squared is a negative 1. So I'm going to go ahead and I'm going to just real briefly, I'm going to cancel out this I squared and call that a negative 1. Right? So now I'm multiplying by negative 1. So I have 1 minus 6, right? Because 6 times my negative 1, plus 5i. And now I can just collect these two. So I have a negative 5 plus 5i. Now I've had people ask me in the past, should you like factor out so that this says negative 5 and then it's going to be 1 minus I? You can, but unless you're specifically told to do that in the directions on the quizzes or on the homework, this is perfectly acceptable. This is the correct answer. Okay, so now on this one's a little bit different since the whole thing is being squared here, and I want to point out that there's a cheat. And the cheat is that when you have something like this, if I have an a plus a b, and I realize that this is a negative, but this works for both as well, okay? This is going to be my a squared plus 2ab, oops, let me erase that, plus 2ab plus b squared. So at this point, I'm going to go ahead and use that cheat to help me solve my problem here of this. Okay, so I'm going to have a 3 squared, my 3 squared, plus 2 times 21i, because I have my 7 and my 3, and that's going to be a negative 21i. And then I'm going to have my 49i squared. Alright, so now I'm going to go ahead and work through some of this. I'm going to have a 9 plus a negative 42i. And then remember, this is going to be the same as a negative 1, so I'm going to just quick do that. Right? So that's going to give me a negative 1. So now I have a negative 49. Negative 49. So I have a 9 minus 49. That's going to give me a negative 40 minus 42i. Now, you could also say plus a negative 42i like I did kind of up here. Either one is correct, so I wouldn't worry about that too much. Right? So I'm hoping that it's becoming real clear that this is just like you would multiply using a variable with the one exception that once you hit that I squared at the end, you have to convert that to a -1, and then you have to combine it with my other real numbers, if there are any. All right. So here's where it gets interesting. And I think this is actually really cool, but I want to make certain that we're real clear on what's happening. First of all, we're trying to divide by a complex number, and that's sort of like trying to divide by an irrational number. We can't do it. So what we've got to do is we've got to change things up. And we're going to change things up by using what's called the complex conjugate. And so it's going to take, and we're only doing this from the denominator information. We're not using the numerator information to build a complex conjugate. We only use the denominator. So here I have a 1 minus 6i. Well, my complex conjugate for that, right, is going to be 1 plus 6i. All right, that is going to be the complex conjugate because the first part stays exactly the same, the real part stays exactly the same, and then the imaginary part, we take the opposite sign. So in this case it was negative, so this becomes positive, and I guess I don't have any that have a positive in the denominator. But if I had a positive here, then I would use the negative. So again, it all depends on what the sign is on your imaginary part of the complex number in the denominator. All right, I realize that again is a mouthful, but we're going to go with it. So I have 2 minus 5i all over 1 plus 6i times, nope, I wanted that to be a negative. That's a negative I, 6i here, on this version, right? So I've just rewritten this piece. Now I'm going to multiply the numerator and the denominator by my complex conjugate. And I'm doing that because I'm multiplying by a 1. As long as I multiply by a 1, all I'm doing, you know, it just gives me the same number. It just going to look a little different, right? Remember that identity property? That's this in operation. We're multiplying by a 1 even though it doesn't look like 1. All right, so here we're going to go ahead. We treat it just like it's a multiplication problem. Here I'm going to have my 2 plus 12i minus 5i minus 30i squared. That's going to be my numerator. And here I'm going to show you another cheat. All right. So here, and I'm going to do this. I'll do this in black so it's a little more obvious that it's a cheat. So when I have something that's an a plus b times an a minus b, what happens is I get an a squared minus a b squared. All right. This middle part, the 9a and the negative, or I'm sorry, not 9, the ab and the negative AB cancel out. All right, so that goes to 0, which is why we can do this step. So I'm going to go back. I'm going to just plug this in. So now I've got 1, and I'm going to have a negative 36i squared. All right, so collecting everything together, this is going to become a 7, right? 7i. And then this becomes a negative 1. And this becomes a negative 1. So when I go ahead and I do that, I wind up with negative 28, right? Negative 28, because this, oh, no, I'm mistaken here. I have a negative on that, so that's going to become a positive 32. My mistake. So here's a negative 30 times a negative 1 that's going to get me positive 30 plus 2. So I'm going to have a 32 for my real portion, and then I have a 7i for the imaginary portion, and that's for my numerator. And now in my denominator, that's going to become a 37 because I have a 1 times, or 1 plus a negative 36 times a negative 1. So that's going to give me a positive 36. I have 1 plus 36, which is going to give me a 37. And that is going to be my answer. I can now actually do some division because I have a real number, not a complex or an imaginary number. All right, so let's go ahead. I'm going to pick another color and do the next problem. I'm going to just write it out, and I'm not going to spend a whole lot of time explaining again, but this is, and I want to point out here, I've written this kind of backwards to what it normally is. You'll almost always see this. But if you wind up, when you're working on something and you wind up with this format, that's fine. Okay? It will get you the same number ultimately. So I have 8i plus 7 over 4 minus 7i times 4 plus 7i over 4 plus 7i. All right. So here I'm going to have 32i and I'm going to have a 56i squared, and then I'm going to have 28, and I'm going to have 49i. So I'm going to use my commutative property, and again I'm going to just quick remind myself that this is going to be the same as multiplying by a -1. All right, so here we go. Actually, let me go ahead and do the denominator first before I go collecting things. Oops, I meant that to be a gray. There we go. So here I'm going to have my 16 plus or minus a 49i squared, which again is going to give me that I squared is going to be a -1, right? So that becomes a -1 that I'm multiplying by. All right, so back to my gray here. I'm going to have a 32i plus a 49i. 32i plus 49i, and then I have -56 plus 28. And that's all going to be over 16 plus 49. So that's going to become a 65. And here I'm going to have a -28 when I collect these two together. And then here I'm going to have a 60, 71, 81 plus 81, oops, 81i. Gotta put the 1 before I put that I. All right. So 81i. And there's my solution. Now I'm going to stop since this is getting a little long. Try to work this last one out on your own. See if you can find your own complex conjugate.